Hello everyone, welcome back to the channel. So you might have heard that Leetcode has certain patterns that if you master them, you will be able to do a lot of questions very easily. So today we are going to see that particular strategy and technique in action. So I've written down a couple of problems here for you, and as we go through them, we are going to cover this one today. As we go through them, you are going to observe that each of them follows the same strategy. Okay, I'm not going to simply tell you what that strategy is, but we are going to build that strategy up intuitively. Okay, so let's first have a look at what the problem statement says for subarray sum equals k, which is Leetcode 560. Given an integer array nums and an integer k, so you're given two things, an array and k, return the total number of sub arrays. Keep in mind that sub array is a contiguous non-empty sequence. Contiguous. Okay, there's a difference between what a subarray is and what a subsequence is. In a subsequence, you can skip elements in between. So for example, 1 2 3, this is an array, right? 1 comma 3, if I take these two elements 1 and 3, that would be a subsequence but not in subarray. Okay, keep that in mind. So we need to return the total number of subarrays whose sum equals k. Okay, whose sum equals k. So the very first approach that comes to my mind, and that would come to your mind as well, is sort of a sliding window approach, isn't it? So what we do is take this particular test case, and we have two pointers I and j, where I is the start of the window and j is the end of the window. And what I'll do is I will take a variable which is known as sum, which basically keeps track of what the sum is of the current window. Now the good thing about both of these two arrays is that they are sorted, and even if they weren't sorted, now I can't sort them because we are talking about subarrays, right? So I can't mess with the indexes. Yeah, that is very important. Okay, so what I'll do is whatever number is being pointed by j, I will add that to my sum and I'll increment my j. Now the sum is still less than 2, so I will add this one to the sum and it becomes 2. So that means that this particular window starting from I and ending at j constitutes a good answer. So what I'll do is, my answer was initially 0, I'll increment it by 1. And now what is to it's time to decrease, it's time to shrink the window, isn't it? So what I will do is I will exit the number which is being pointed by the I pointer from the window. I'll increment my I, so my sum actually becomes 1. Okay, then again I increment my j, I add this one to the sum, it becomes 2, which is equals to k, so I increment my answer, right? I decrement my I, it comes at this point, then when I increment my j, it goes out of bound, and 2 is my answer, isn't it? Similarly over here as well, right? I will take a sum variable which is initialized to 0, I will take an answer variable which is initialized to 0, I will add this one to the sum, again not equals to 3. Okay, no worries, I will take this 2, I will add this to the sum. Okay, what does this become? This becomes 3, which is equals to k, so I'll increment my answer. At this point I will shrink my window. Okay, I shrink my window, it comes at this point, so I need to remove the 1 from my sum, right? It becomes 2. Then when I increment my j pointer, the sum now becomes 5, and then 5 is actually greater than k, isn't it? So when do we shrink our window? We shrink our window when we get a number, when we get a sum which is greater than equal to k, isn't it? Now since sum is greater than 3, I need to shrink my window, isn't it? I need to exit this 2. So when I increment the I remove 2 from it, it becomes equals to 3. So I increment my answer, and that makes a lot of sense as well, right? You have basically two subarrays, 1 comma 2 and then 3 alone, which have a sum of k equals 3. So this was clearly very simply a sliding window approach, right? That's the first thought which came up into our mind. So let's first try to implement that. Okay, let's see if it passes all the test cases. So I have int I equals 0, int j equals 0, then I have int sum equals 0 and answer equals 0, right? Then I am iterating while j is less than nums dot size. So I need to iterate till the end of nums, and what I do is I add sum plus equals what, nums of j, not nums of I, nums of j, because the ith pointer is used to shrink the window. We are expanding the window right now using the j pointer. Okay, okay, perfect. Then I add one, for example, I add this one to the sum. Then when I add this one to the sum, what happens? The sum becomes equal to, or I can have a just a while loop. I won't need the while loop. Yeah, I think I would need the while loop, because there could be a scenario something like this, if k equals 3, and you have something like 1, 2, 3, 4, and then 10, something like this, or maybe something like 1, 2, 3. Okay, so, and let's say that your k is 3, so this would be a subarray, then this would be a subarray. So there's going to be a point where both I and j are over here, right? Then basically what I'm trying to say is that there can be a point that you'll have to increment I by more than one steps, one plus steps, in order to make sure that the sum that you have uh, gets below k. In both of these scenarios, when we incremented the I just by one step, we got the sum below or equals to k, below k basically, right? But there could be some scenario where you have to increment the I more than one steps. That's why I'm not using a if statement over here. I'm using a while statement. Okay, so I'm going to say while sum is greater than equals to k, greater than equals, right? Because we increment the I even when our sum is equals to k. You must remember that from the example test cases. So while the sum is greater than equals to k, what we do is we subtract nums of I from it, we exit the number which is being pointed by nums of I, okay, and then we increment the I. Perfect, perfect. Okay, and just for safety, no, I won't need that condition. I is less than nums of j. I don't think so. So sum minus equal nums of I, perfect. Or let's just add it. What harm does it do to us? Nums of I is less than nums of size, perfect. Okay. But before this, what will I need to do? I will need to um have a condition. Should that condition be inside the while loop or outside the while loop? I don't know. Let's keep for now. Let's keep it outside the while loop. So while if the sum is equals k, what do? I increment the answer. Yeah, perfect. Okay, and we shrink the window over here, and in the end, what we are going to do over here is we are going to return the answer. Yeah, let's see if it passes all the test cases. Time limit exceeded. Because I'm not incrementing the j, right? J should be incremented at each and every iteration. I almost always forget that for some reason. This gives us the correct output, but then for 1, 2, and 3, the output which we are getting is 1 rather than 2. Why is that? Um, why is that? So let's if I dry run my code, then I have 1, 2, and 3, right? 1, 2, and 3. Perfect. I have 1, 2, and 3. Then what we are doing is we are doing something like this. The I is 0, the j is 0, the sum and answer is also 0. Sum is 0 and the answer is also 0. Perfect. Then so this becomes 1, nothing happens, j plus plus. Okay, so sum plus equal nums of j becomes equals to 3. Perfect. Answer becomes equals to 1. While sum is greater than equals to k, sum minus equal nums of I, so it becomes this should have been inside the while loop. You see, that is exactly what I was saying. So after or before, let's keep it over here. Let's see. Yeah, accepted. And let's see uh, if we test it over all the test cases, let's say if it passes them. No, it does not. So what if I have -1, -1, 1 and k equals 0? So there should have been, this subarray should have given me should have given me uh, zero sum, right? -1, -1, 1. So let's see why this test case is not passing. I have -1, -1, 1, and the k is equals to 0, right? Let's see why this is not being passed. So if we run our algorithm on it, my answer is 0, my sum is 0, right? I'm going to increment the I, the sum is going to become what? -1. Then again, it's not greater than equals to k, right? It's going to become -2, again not greater than equal to 0. And since it's not greater than equals to, sorry, not greater than equals to k, I'm not going to shrink the window, right? Then when I increment the j, this becomes -1. So that's a problem for us. That's a problem. When do I shrink the window, right? I was shrinking the window at this condition, but I what I missed was the constraints, isn't it? The constraints clearly tell me that that number of I could be negative as well. So this tells us that the sliding window approach probably doesn't work, isn't it? I need to think of something other than this. In order to achieve the same purpose, in order to count the subarrays with the sum equals to k, I need to do something else. So what would that strategy be? Let's see. So I have -1, -1, 1, okay, and I have the k equals 0. Some other test cases included 1, 1, and 1, and the k was equals to 2. And then we had 1, 2, and 3, where the k was equals to 3. So what can I do over here? You see, this subarray has a sum of 2, and this subarray has a sum of 2 as well. So can I maybe use prefix sums somehow? Because this subarray is going to have a prefix sum of 2, and this subarray is going to have a prefix sum of 2. Similarly, this is going to have a prefix sum of 2, and then this alone is going to have a sum of 2, sum of 3 as well. Not 2, 3, I mean, right? So let's try something on this level, on prefix sums level. Okay, so what I will do is, initially I have the sum as 0, right? Initially I have the sum as 0, and I will take a map in order to store all the sums that I have encountered. Now why am I taking a map? Let's see if this has got a particular reason. So my I is over here, my j is over here. Okay, perfect. Or let's not take the j, we are not using sliding window, let's just take a single pointer. So my sum was equals to 0, I recorded that in the map. Now my sum is equals to 1, right? So I will record that in the map as well. Okay, perfect. Now my sum gets equals to, it was previously 1 at this point, now it gets equals to 2, isn't it? Now it gets equals to 2. So what I'll do is, I know that this 2 is equals to this 2, so I'll just directly go and increment the answer to 1, right? And what I'm saying is, what extra thing I'm saying is that rather than only incrementing the answer variable, what I'm going to do is, I'm going to keep track of this 2 inside the map as well. Why am I doing that? We have no idea till this point, right? Why I'm doing that. Then when I increment my I and I reach this point, the sum is equals to 3. Now 3 is not equals to 2, but then we know that this particular subarray has a sum of 2, isn't it? This particular subarray has a sum of 2. And that is exactly why we take a map. You see, because the map tells us that you had one subarray which had a sum of 1. So if your total sum is 3, and if sum till this point was 1, then what does that mean? That the sum from here to here must have been 2. Are you getting my point? So even though that the sum is 3, I'm going to search inside the map what I'm going to search inside the map sum minus k, which is equals to 3 minus 2 1, and I did have that. So I'm going to add this particular number over here. So this becomes equals to 2. Are you getting my point? And why exactly this particular number and not just do answer plus plus? That we are going to see as well. Why do we add this particular number? There must be a reason, right? And we are going to see that. For now, let's just assume that I increment the answer. I do answer plus plus, something like that. So you get the intuition behind it, right? Similarly, for example, if I run it over the test case 1 2 3, if I run this technique over the test case 1 2 3, so I'll take a map. Initially my sum is 0. So I will keep a track of that. Okay, my I is over here. The sum becomes equals to 1, k was 3, right? Now sum becomes equal, so 1 I incremented, right? Sum becomes equals to 3. At this point I'm going to search what? Sum minus k inside the map. Do I have 3 minus 3 inside the map? Yes, I do. Yes, I do. So what I'm going to do is I'm going to increment the answer. I'm going to make it 1, and that is exactly why I keep track of the zero sum as well. Because what if you have a subarray which is exactly equals to 3, isn't it? Which has a sum which is exactly equals to 3. So you need to keep track of this 0 as well. So my answer becomes 1, right? Then when I increment my I, the sum becomes equals to 6. But 6 is not equals to k. But then when I do sum minus k, when I do 6 minus 3, I already had 3 inside of my map from this point. When my sum was 3, I kept track of its frequency. Now it's present inside my map. That means that the sum till this point is 6, but then till this point it must have definitely been 3, which means that the sum from the end of this to the start of this thing is also 3, which we need. Are you getting it? That is why I am searching for sum minus k inside the map. So I will increment my answer and it becomes 2. Sorry. Okay, let's now run it over the last test case, which is this one, -1, -1, 1, so that just we are able to make sense of how things are working. Okay, so just like before, I'm going to take a sum variable. I'm going to take a sum variable as 0, answer variable as 0, and I'm going to keep track of this 0 as well, right? We know the reason for that. So my I is over here. My sum becomes equals to -1. Okay, I keep track of that -1. Perfect. Then at each and every point I'm going to be, this for a fact, I'm going to be searching for sum minus k inside of my map. So sum minus k is going to be -1 minus 0, right? So that was initially not present inside my array. Now my sum becomes equals to -2, and then at this point my sum becomes equals to what? -1. So before I actually add to the frequency of -1, what am I going to do? Before I add the frequency, before I make this 2, I'm going to search for sum minus k. What is sum minus k? Sum minus k is -1 minus 0, which is -1, and I do have that present inside the map. That is why I'm going to do ans plus plus. What does this mean? This means that the sum, let me tell you from the very start. The sum till this point was -1, the sum till this point was -2, and the sum till this point again is -1. What does that mean? That means that if this particular subarray is -1 and if this whole thing is -1 as well, then there's 101% chance that this particular part of this particular subarray, this particular part of the array is adding nothing to the overall answer, right? This is +0 because you have -1 over here and then you have -1 overall as well. What does that mean? That means that this particular part 100% must have been 0, right? 100%. So that is why we increment our answer. So let's now do that inside of our coding environment. Okay, I hope the intuition was clear though. I will just reset to default, and what we do is, so first of all, let's just calculate nums dot size. Do the standard procedure. Let's take a map of integer comma integer, call it MP, and as soon as we create the map, chalo, what we'll do is we will uh, set the frequency of 0 as 1. Why? Because we know that our sum is initially 0 and we need to keep track of that as well. Answer is equal to 0 as well. Perfect. Then what we do is we say that I is equal to 0, and while I is less than n, what we need to be doing is I plus plus. Perfect. We could have used a for loop as well. It totally depends upon you. Then what we do is what do? We say sum plus equals what? We take the prefix sum, basically sum plus equals nums of I, and then before incrementing. So for example, when I was at this position, before making it 2, because I got this -1 for the second time, so I must have made it 2 as well, right? But before incrementing the frequency, I search. I search first, then I increment the frequency. And what do I search? I search sum minus k inside of my map. Why? This is the intuition, right? Perfect. So yeah, before I increment the frequency, I need to search whether I had a subarray which had a particular sum. So if sum mp dot find sum minus k is not equals to mp dot end, what I said was that we are going to do ans plus equals mp of sum minus k. But right now we are not doing that. Right now what we are doing is ans plus equals 1. And we are going to see why this is wrong. It is going to pass our example test cases, but then that's wrong. We are going to see why. Nothing, we are going to do nothing without proper reasoning. Everything will be with proper intuition and with proper logic. So after I have searched it, what I will do is I'll increment the frequency. Okay, so a map of sum plus plus. Perfect. And then ultimately, what do I return? I return the answer. Let's see if it's going to pass the example test cases, but then it's certainly not going to pass all of the test cases. Why? Because this is the reason, and I'll tell you why. Okay, so it does not. 1 -1 0. This is a very good test case. You see, this is a very good test case. 1 -1 0 and the k is 0. Let's have a look at that. Okay, so I have 1, I have -1, and I have 0. A very good test case. Let's see. Say I have a sum as 0, I have answer as 0 as well, and what I'll do is I will increment the count of 0 inside of my map. My I is at this point, so the sum becomes equals to 1. Okay, what did we say? We said that we are going to search sum minus k inside the map before we keep track of the frequency. So 1 minus 0 is 1. 1 is not present inside the map, so nothing to worry about. What I'll do is I will just increment the frequency of 1. Then I increment my I. Okay, so the sum becomes equals to 0 again, which means dekho, which means that initially when you took nothing, the sum was equals to 0. After you have taken two things, now again the sum is equals to 0, which means that this particular subarray has a cumulative sum of 0, right? Perfect. So what did I say? We said that we are going to increment our answer by 1. Okay, let's do that. Perfect. Then what happens? We get 0. So again the sum is equals to 0. And what, according to our strategy, we should make this sum, we should make the answer as 2, and that is exactly what we were doing. We were returning 2, but they're saying that 3 is the correct answer. And how is that, so? Let's have a look. How do we have 3 subarrays rather than 2? Think about it. You see, I have this particular subarray whose sum is 0. I have this particular subarray whose sum is 0, and then this 0 alone is also a subarray, right? So 1, 2 and 3, isn't it? 1, 2 and 3, right? So, when I encountered this one, so let's come back a little, come back some steps. At this point, at this point, my sum was 0, right? At this point, my sum was 1. I kept track of it, perfect. Then at this point, my sum was 0. So what I will do is, I will add this to my answer. Okay, my answer is going to become 1. From 0, it's going to become 1. And then I'm going to increment this, because I will say that initially when I had taken nothing, the sum was 0. After I have taken 2 things, the sum is again 0. So I'm going to increment this. Perfect, perfect. And again at this point, the sum is 0. So what I should do is, rather than just incrementing answer, I should add this particular number inside my answer so that it becomes 3. Why am I doing so? What's the reasoning behind this? This tells me that you just don't have one subarray. You have this one, you have this entire one as well, and then you have this 0 as well. And this is going to be present in a lot of different test cases as well, right? So I hope you get the intuition behind why we need to add MP of sum minus k over here. Why we need to add MP of 0 rather than just blindly incrementing it. Okay, right? So the the example test cases get passed, and if I submit this particular code, then it passes all the test cases again. So we have successfully done the first question of our patterns, which was subarray sum equals k, and this actually made us learn a very important concept, which we can we are going to take this exact concept and we are going to apply it at several different places. Okay, but we did not just stumble upon the concept by reading the editorial. We first tried what our gut told us to do, which was sliding window. And then when we saw that sliding window was failing at negative numbers, then we said that, can we do something on the level of prefix sum? And what if I what if I record, for example, if I have 1, 1 and 1, what if I record that the sum till this point, was 1, and the sum till this point is 3. So if this is 1 and if this is 3, then this must have been 2, isn't it? Because 1 plus 2 is equal to 3. So that is how this particular subarray has a sum which is equals to k is equals to 2. And in order to keep track of all the sums which we were getting, what did we do? We used a map. Okay, so we are going to take this exact same strategy and we are going to apply it to the other questions as well. Do think about the time and space complexity over here. I will leave that on you as a homework. Do mention it in the comments, and I hope you found the video helpful. I'll see you in the next one.